This is an example of a logarithmic equation. Yesterday we solved exponential equations. Exponential equations is when the variable is in the exponent. Logarithmic equations is when the variable is inside of a logarithm. When we solved our exponential equations, we got really good at expanding things because that's how we got the x out of the exponent. Solving logarithmic equations are the opposite. We're going to get really good at simplifying the expression. In fact, our main goal will be to write the equation as a single logarithm. That's going to be our main goal. So whereas with solving exponential equations, you expanded to get the x's out of the exponents, with solving logarithmic equations, you're going to want to combine things. Combine it into a single logarithm. The reason for that is once you've combined it as a single logarithm, you can then use the definition of a logarithm and change it to exponential form. So this is the first main goal, and the reason we need to write it as a single logarithm is so that we can use our definition to change it to exponential form. So what does that look like? Well, in this equation, we've got two logs, log 3 of 9x plus log 3 of x equals 4. Do you have a log law that could put those together as a single log? Yes. Adding two logs with the same base is the same as multiplying inside. So I could write this as log 3 of 9x squared equals 4. At this point, we've completed our main goal. We wrote it as a single logarithm. We now can take this single logarithm and change it to exponential form. And when we change it to exponential form, in this case, the base is 3, the exponent is 4, it's equal to 9x squared. It changes into something that you already know how to solve. How do you solve something with an x squared? Well, this is 81 equals 9x squared. Divide both sides by 9. And square root, in which case you'll get x equals 3 and x equals negative 3. Remember, when you square root both sides, you have to remember the plus or minus. The last thing that happens in log equations is you need to check your answers for something that's called extraneous roots. Now in math, extraneous roots are answers that appear to be right, but when you check them later, they actually aren't correct. So in this case, the basic thing that you're going to be looking for when you check for extraneous roots is the main fact that you can't take the logarithm of a negative number. If you think about, if I just draw a quick sketch of a log graph, right? A log graph has an asymptote right there and looks like this. The domain of a log graph is x is bigger than 0. You cannot take the log of a negative number. You can't take the log of 0 either. So those are outside of our domain. So we've got our two answers. We've got our answer of 3 and negative 3. I'm going to take those answers and plug them back into my original equation. So when I plug in 3, what's 9 times 3? 27. It's positive. It's fine. Check the second log. Log 3 of 3. It's positive. You don't have to check to make sure that it works. There's no left side equals right side or anything like that. You're just checking if it's positive in every log, we're going to assume our algebra is correct, and that answer works. But with negative 3, if I plug negative 3 into the first one, 9 times negative 3 is negative 27. Can't take the log of a negative number. You don't even have to check any further. We know that that is an extraneous root. And so the only answer is x equals 3. someone saying, oh, good, I always forget the plus or minus. So if I was solving this one, I would just naturally forget the plus or minus and just write x equals 3. Would I get full marks? No. So you have to show that you know that there's two possible ones and show that you know that that one doesn't exist. Even if you can do it in your head. Okay? They expect all of our answers to be shown and show that you're rejecting one. Because in this case, I can't tell as the teacher, did you know that it was plus or minus and rejected the minus? Or did you just screw up and got it right? Two negatives make a positive kind of thing.
But like, hypothetically, every time you square root, it'll always be a positive answer.
Right, but I could make a log equation where it's a positive and a negative, but they both work, depending on how I set this up, right? This equation was set up like this. Had this been the start of the equation, then both the positive and negative would work. Because if you plug negative 3 into here, you get positive 81. This equation, if I call this equation 1 and this equation 2, they have different domains. The domain of this equation is x is bigger than 0. The domain of this equation is all real numbers except x can't equal 0. So they're different. They're the same equation in the fact that you will get the same answers, but they're different equations in their domain. This one allows for negative numbers.
Wait, how are they different numbers or different equations? You're just simplifying the first equation.
You're simplifying it, but as soon as I combine this, the equation number 2 allows for negative numbers. That's why negative 3 appeared as an answer. But equation number 1 doesn't allow for negative answers. It's the same thing. You had something similar with this when you had equations that look like this. X plus 1 equaled 3. X. Okay? Now, how do you solve an equation like this? You learned that you square both sides. The act of squaring both sides creates a possibility that you might make a mistake. Oh, and this one doesn't have a nice answer. But if you would solve this, here I'll think of one that has a nice answer. Here we go. Let's go. X3. There, this has a nicer answer. So you square both sides. You get x plus 1 equals 4x squared minus 8x plus 4. Okay? You move everything over and make one side equal to 0. So you have 4x squared minus 9x plus 3. If I did everything right, this should factor nicely. X minus 3, 4x minus 1. No, that doesn't work out nice, does it? No, I made it so it didn't work out to nice numbers again. Anyways, sorry, I'm trying to think off the top of my head to have nice numbers, and I screwed up twice in a row. But if you would get nice numbers and you'd factor it, sometimes you will get an answer that doesn't work because it makes you take the square root of a negative number. So this act of squaring, which you did in grade 11, meant that you had to check for extraneous roots. The same thing happens here with logarithms. The act of putting the logarithms together may cause an extraneous root to appear, so you always have to check with logarithms if that's the case. Okay, so questions I'd like you to work on right now. 5 minutes. 3, 4, and 9. I want you to do one of question 3 and then start on 4A right away, because I want to talk about that one.